Hello, my name is Sanyoung Ro, and this is my final project for programming machine learning. My project is called NewsVali, an ML-based news verification support program. The goal is not to automatically decide whether a news article is true or false. Instead, NewsVali helps users identify sentences that may require further verification. It highlights potentially check-worthy sentences so the user can review them more easily. Project goal and main tasks. NewsVali performs sentence-level classification. The user enters an article and the application splits it into sentences. Each sentence is converted into TF-IDF features and classified by a trained model. The application then highlights sentences as needs verification, suspicious, or likely reliable. These labels are only used to guide the user's attention. They are not final fact-checking decisions. System architecture. This slide shows the overall workflow. For the training pipeline, I prepared the datasets, extracted TF-IDF features, trained and tuned models, evaluated them, and saved the model artifacts. For the application workflow, the app loads the saved model in Vectorizer, processes a user article sentence by sentence, and displays highlighted output. This separation lets the application use the trained model without rerunning the full experiment pipeline. Dataset and pre-processing. For training, I combined 3 public fact-checking and verification-related datasets: Beaver, Liar, and Multi-FC. Because these datasets use different label formats, I mapped them into a common binary setting: likely, reliable, and needs verification. After label mapping, I cleaned the text, removed duplicate claims, created an 80-20 stratified train test split, and trained TF-IDF vectorizer on the training data. I also created a small custom evaluation set with 5 real articles and manually modified claims. This custom set was only used for application level evaluation. Machine learning methods. I tested 4 traditional machine learning models: Logistic Regression, Linear SVM, Random Forest, and Gradient Boosting. All models used the same TF-IDF representation with unigrams and bigrams. For tuning, I used random search first, then grid search on a refined parameter range. I used F1 score as the main tuning metric because the application needs to balance missing important sentences and highlighting too many sentences. Result summary. In the model level results, gradient boosting had the highest accuracy and precision, but its recall was lower. This means it was more conservative. Linear SVM had the highest F1 score, so it gave the best balance between precision and recall. For the application level test, the models behaved differently. Logistic regression highlighted the most sentences, gradient boosting highlighted the fewest, and random forest had the highest useful highlight. Overall, the system can support sentence level review. Missed cases show the limits of claim-only TF-IDF classification. Conclusion and doom. The main limitation is that claim text alone does not always show whether something is worth checking. TF-IDF captures surface words, but it does not understand evidence or article context. Future work would include evidence-aware features, sentence BERT embeddings, a larger article-level evaluation set, and better threshold tuning. Now I will show a short demo of the working NewsVali application. This is the NewsVali application. There is the article panel on the left side. At the top, I can choose one of the custom test articles from the dropdown. I also can choose the trained model from the model dropdown, so the app can compare how different saved models behave. When I choose a different article or different trained model from dropdown, the app automatically updates the prediction results. The app splits the selected article into sentences, runs the selected model, and highlights the output. Red means needs verification, yellow means suspicious, and unhighlighted text is treated as likely reliable. On the right side, this is the output panel. When I click a highlighted sentence, the app shows the selected sentence, the predicted label, a model score, and a short rule-based explanation. This helps the user inspect why the sentence may need review. If the user wants to test their own article, they can click Clear, paste new article text into the left panel, and then click Analyze Article. The app will run the currently selected model on the new article and update highlighted output. The exit button closes the application. Finally, I also built a small command line experiment manager for the machine learning workflow. This tool is separate from the desktop application. It lets me train, tune, and test saved models in a more organized way. In this example, I select a saved model, and the program loads it, evaluates it on the test set, and prints the final metrics, including accuracy, precision, recall, F1 score, and confusion matrix counts. This shows that NewsVali includes both the experiment pipeline and the working desktop application. That completes the demo.